Most students lose points on calculus exams because they mess up the limits or forget a simple negative sign. Today, we are going to solve two classic integration problems, one using the power rule and one using U substitution. For part A, we have a definite integral with a fraction. Don't let the x in the denominator scare you. The trick? Rewrite it. We have the integral from 1 over 2 to 1 over 4 of 2 over x to the fifth power, dx. We move the x to the fifth power to the top. Remember to make your exponent negative when moving it. Now we have 2x to the power negative 5. Isn't it easier to work with that now? Let's apply the power rule now to integrate our term. So 2x to the power of negative 5 will become negative 1 over 2 times x to the fourth power. Therefore, the integral of 2 over x to the fifth power, dx will become negative 1 over 2x to the fourth power, with limits between 1 over 4 to 1 over 2. Let's evaluate the limits by substituting our upper and lower bounds. We will start with the upper limit. When x equals 1 over 4, we get negative 128. Next, we substitute the lower limit. When x equals 1 over 2, we get negative 8. Finally, subtract the lower limit from the upper limit. Negative 128 minus negative 8 equals negative 120. All right, let's have a look at part B. We are breaking down a definite integral that looks complex at first glance, but is actually a perfect example for one of the most powerful techniques in calculus, U substitution. Take a look at the integrand. We have the function x to the fifth power plus 1, all to the fourth power, multiplied by 25x to the fourth power. The key to U substitution is identifying a core function whose derivative also appears in the expression. Notice that the derivative of x to the fifth power is 5x to the fourth power. Since x to the fourth power is present, we know U substitution will work. Let's start by letting U equal the inner function, x to the fifth power plus 1. Now, we find the differential, du, by taking the derivative of u with respect to x. We get du equals 5x to the fourth power, dx. Our integral has 25x to the fourth power, dx. To make our substitution clean, we can rewrite it as 5 times 5x to the fourth power. This means 25x to the fourth power, dx, is equivalent to 5 du. Now, let's have a look at our boundaries, or limits. This is a definite integral, meaning it has upper and lower limits. Since we are changing our variable from x to u, we must also change our limits of integration to match the u limits. We can do that by substituting the original x limits into the u equation. U equal x to the fifth power plus 1. For the upper limit, u equals 1 to the fifth power plus 1 equals 2. For the lower limit, u equals negative 1 to the fifth power plus 1 equals 0. So, our new interval of integration is from 0 to 2. Now let's rewrite the entire integral in terms of u. We already know that x to the fifth power plus 1, all to the fourth power, can be replaced by u to the fourth power. As for 25x to the fourth power, dx, we can replace it by 5 du. Finally, for the integration limits, we already found our new limits, 0 to 2. So our new expression is the integral from 0 to 2 of 5u to the fourth power, du. This is now a standard integral that we can solve using the fundamental theorem of calculus. To evaluate the new expression, we apply the power rule for integration. The integral of fourth power is u to the fifth power. Now we can evaluate our upper and lower limits. For the upper limit, 2 to the fifth power equals 32. For the lower limit, 0 to the fifth power equals 0. Our final step is to subtract the lower from the upper limit. So 32 minus 0 equals 32. If this step-by-step breakdown helped you understand the concept, hit the like and subscribe button for more math tutorials.